Hello, I'm Bill Wake. I'm here to summarize the work I did last week on Twitch, working on a kaleidoscope. The three things we focused on are the motion, the boundaries, and files. So let's see what those came like. Up till now, I've just used the little pinch gesture to rotate things, but we really would like the device to rotate. So let's see if I can... So I've got it on my iPad because it's a physical motion. The Mac doesn't do that. It's a lot harder to rotate a desktop than a tablet. But you can see as I turn, I'm getting a different picture in my kaleidoscope. All right, and that's not hard to set up. It's just a little paragraph of code that hooks up the motion detection and tying it to an angle. Let's take a look. Okay, so we've pulled this out into a rotated view. I'm not quite sure how I want to do this in the long run, but the core part of it is here. When the picture appears, or the view appears, connect up the motion manager, get an update interval of 20 times a second for us, and tell it whenever it sees a change in motion, call the update handler, which captures the yaw, the side-to-side rotation, converts that to radians, and stores that as the angle. And then angle came in as a binding here. So whoever wants to listen to that angle can adjust themselves when they do. The second thing we worked on is boundaries, and I'm going to show just kind of physically how it works. Well, my understanding was, or what I thought I was doing, was moving the pie around. So I think we had said originally, like, just move it from 1/4 to the left to 1/4 to the right. And notice because the triangle is vertical on one side, it's sticking out on the other side. We didn't want to go all the way over because then you'd be out here. Okay, so we were restricting it horizontally to kind of here to here-ish. Vertically, I did a sine wave pattern, so something like this, bouncing up and down to sort of cover the space. Okay, we won't hit every pixel or anything like that, but we'll hit ones next to each other and look pretty good. Okay, well, that was kind of my thinking about it. What we were really doing was slightly different. So let's go there. What we were seeing was we'd get a white circle in the middle of our picture, even though the picture had no white space, or we'd see the reflections with space between them, or else we could even get to the point where we had so much space between them it was all space and you didn't have any image at all showing. And so we knew something was wrong, and basically we spent a couple days fixing it. First thing was I flipped the y-axis. I mean, I know where it is intellectually. Y = 0 is up here. Okay. Which, I mean, every bit of math I had always put 0, 0 in the corner here. So you could say, sine of 0 is 0 going this way or whatever. But this one, so if I've set the triangle's point to 0, 0, it's up here out of the space. Okay. So definitely various times I forgot about that. Second mistake I made, I had thought I was moving the pie over the image, but I wasn't. What I was really doing was moving the image underneath the pie. Okay. Whether I don't know enough of what I was thinking to know if I realized that at some point and then just kind of didn't think about it because it worked, quote worked. But definitely by the time we got to, a couple days into this week and started looking at this, I was still thinking the pie was moving, but it's the image. Okay, so needed to take that into account. There's funniness, and there still is a little bit of funniness around the edges. So we do an inset. And I think what's going on is if you're right at 0, there's a little ambiguity about, are you in the shape or out of the shape? And, do you maybe have 1 pixel off the edge or something? So rather than worry about that, I just put a little buffer on the side. I don't know. I think it was 20 pixels, and trying to make sure I don't ever hit any direction. So we did a lot of work to make sure things were staying in bounds. Okay. In the improvements. And then the last thing was I forgot the offset needs to be negative to slide up because we're offsetting the picture. So moving the picture up a little bit has the same effect as moving the triangle down. Okay. Which is the effect I'm after, but you needed to negate things. So I spent a lot of time with the sign being flipped because of either the x-axis or the offset going the wrong way to my, my naive intuition. It just, it really was rough. Now, part of it is there's, well, I'm not doing any TDD about most of the visual aspects. The one thing I did TDD though was there's a conversion that says given basically it's given that angle that came from the motion sensor, the yaw, where do you want to draw? Okay. And so I know if X is 0, I want the triangle to be over here somewhere. And if X is, if it's almost 2 pi, almost all the way around, I want to be over here somewhere. Okay. And same vertically, I want to reflect the sine wave stuff. Okay. But, it was so easy to get signs backwards, and I got to dig it up. But there's a James Blinn quote. He's the one who first did the spacecraft simulations of flybys of Jupiter or Saturn or whatever, and he was like, the way to get this right is, because you have all these signs negating each other all the time. You go through it very, very carefully, and then at the end, you probably have to throw in an extra minus, and I felt that same kind of thing, like, oh my gosh, I kept trying to think it through, and that 0 on top really, really burned me a lot. I remember it for half of it, and then by the time I got done to the next thing, I'd forgotten that I had to compensate that way. At one point, we were scaling the image by reversing it vertically and then transposing it back down, and it is a mess. All right, so I made all these errors, probably some more too, and we were. Well, we mostly worked in an experimental tab. So Mike Hill has the notion of a making app versus the shipping app, that sometimes you need stuff in as a developer, you need to be able to do things. So we did simulations of this and pulled out parts of it into the experimental tab and took care of it. All right, so let's take a look at the code. Okay, so this is before on the left. The first part of that, lines 5 through 13, they're basically scaling the angle into 0 to 2 pi minus epsilon to almost 2 pi. And then you can see in 15, we took the 1/4 of the width. So we were sort of starting, a quarter of the way across and trying to get up to the right distance horizontally. Okay, and the working angle divided by pi, well, working angle is 0 to 2 pi, divided by pi is 0 to 2. So 1 plus that is 1 to 3, and 1 to 3/4 plus the original quarter. Okay, so that tells me, like we were trying to push all the way just to the far right, not worrying about like what if it really was exactly at the right or something. I thought I was kind of keeping to the middle, but it's not. That formula doesn't quite do that. It gets really close to the edge, leaving room for the triangle part, the sweep. All right, and then the Y thing, we did something similar. The double sine of X and sine of 10x are always the same, sine of any multiple of x, but it tells you how many repeats you have. So the frequency. I use different numbers. I think I'm at 3 now, but that's to give us some sweep up and down. And so the sine has the range -1 to 1. You do +1, it has the range 0 to 2. And so theoretically divided by 4, times the width. So it again, it was trying to be something, but we're talking the y-axis and I'm talking about width. In a way that's okay, because the image was vertical, and the choosing the width means we were sort of choosing the short side, but we really didn't explicitly calculate that it was the short side. So that would create some problems too if somebody had started up, in landscape instead of portrait or something. But it was trying to keep things in the range of of visible. Now the afterwards, again, I've got this section, and I really should pull this into a method, but it's forcing the angle to be 0 to 2 pi, and the approach now is turn that into a percent. Okay, well, it's 0 to almost 1, so angle divided by 2 pi is 0 to 1. Okay, and then the width we allow, we're going to allow it to be half the width based on, moving across horizontally based on that percentage. So theoretically, if I go back up, this pi should only get that far. So it should be from here to here horizontally. It may be bouncing up and down too. All right. And then the 2y, I also moved to converting that to a percent. So if I take the sine of repeats times radians, that's -1 to 1. Add 1 is 0 to 2. Divide it by 2 gives you 0 to 1. So I've got something in the range 0 to 1. And then I calculate the maximum, half the height, and I calculate half the width, and the radius is going to be the smaller of those two. So now we're taking into account the image, whether it's horizontal or vertical in the first place. All right. And so the radius tells me how tall is that piece of pie. And so I can't go back to that again. If my piece of pie goes above this point, I'm going to start getting into the blank space, and I'm going to start seeing white between my triangles. And if it ever got up here, it's totally white. So we limit the range to be from the bottom of this point to the maximum here, or actually, I think we calculate it the opposite way, from here to here, and then we add in the radius. Okay, so the height, and then slide it back down. Okay, I guess half the height to move it back. So this thing is 0 to 1 times that number of pixels we want up and down, and then kind of work from the halfway. I don't know, that still gives me a twinge. Maybe it's worth another look. All right. And then the last thing that came up for me was, during the discussion of this, somebody suggested we make a 3x3 tile, so we knew we wouldn't get out of range. And I didn't really want to try and do that. I felt that would be kind of more complicated. That we should, even then we'd still have to know whether we were in the range of the 3x3. So it seemed like, well, just get it in the range right. But I think I should adapt that idea and make one copy flipped, because what happens now is you get halfway, and if you move a little bit, you've wrapped around. Well, you were looking at a slice of tomato and corn, and then all of a sudden, bang, you're looking at empty marble and a tassel. It's not so smooth. But if I did this with the reflected one, get that out of the way, I could slide over to 100%, and then when I'm all the way over here, wrap around to looking at this part of the image, and it would be a much smoother transition. I don't think it's horrible, but you definitely get a flash as you shift from halfway to the beginning. And also it would use more of the picture, which also seems like a good thing. All right. So that was painful. The tests were all testing this method, but we did a lot of the work without tests, and then went back and made sure the test cases had the angles we expected with the new code. Very backwards to my normal TDD style, but so TDD helped with the boundary cases because we kind of worked through the expected boundary cases. The original results, well, I should say it this way. We had tested this one pretty thoroughly, I thought. I think it got the answer. Well, it got the answers we expected in this one, but the behavior was not the behavior we wanted because it picked up too much blank space. Then we corrected the code to what we thought it should be, and then went back and made sure all those test cases had the right answers. And I did try to consciously calculate the right answer and then plug it in, not just take whatever came out. All right. And then we use that making app idea. So, basically this visualization was our screen for a while, and we could look at what happened with this stuff. That helped a lot. Okay. And then the last bit we did was just selecting a file. So I'll just show that in here rather than bring up a full demo. You were looking at a kaleidoscope image. If you click on down on select a photo, you can go to a photo picker that goes through your iPhoto album or whatever, and you can select a new picture, and then the kaleidoscope shifts to that. So before this week, we just had one hard-coded picture that we always used, and now you can at least select those from there. Now, what I expect to do in the coming week, well, sorry, I'm off next week and the week after, but when I'm back, what I'd like to do is see if we can get the live camera view. So you could hold the camera and pan around the room and get that kaleidoscope effect based on what you're looking at in the room. And then my longer term one, if I stick with the project long enough, iOS has this Scene Kit 3D or something like that that lets you create a little 3D environment, and you can add physics like gravity and stuff to it. So my thought is to put a number of objects in a little, hopefully I can make it feel like an oil thing, so it rotates or drops a little slowly, a little slower the gravity. But I'd like to be able to do that. So you could maybe select a few starting points and see like little translucent gems or things like that. I don't know if I'll stick with that or not, but I do want to get the camera one working if I can get access to that live camera. But it's been a good project so far. It's interesting feeling to me like, oh, I can't really TDD some of this visual stuff, trying to find little corners where I can. And there may be some other places where I could do something, but mostly I try like the rotation. We isolated that out so there's something that rotates a view depending on the physical place, physical rotation. At least that piece is pretty isolated. So we'll see. I don't know, like accessing system things like the camera and the photo album, by the time you mock it, I just don't know that you're getting any great benefit compared to like making sure it works. But the angle stuff, we definitely needed help with that. So I don't know, we'll see. I've got a little cleanup to do on the angles, I think. I may put that reflection idea, I forget who suggested it, but, borrow just that piece of it, just one reflection, and see if we can smooth out the transition on the image. But I think we're making good progress. All right, well, thanks for watching the summary, and have a good week yourself. Bye-bye.